No, I'm very glad to be the one demo of the day that has given the sacrifice to the demo gods. Happy to be that tribute. So today I'm here to talk about a time in Honeycomb's life. As a company, we had been around for several years, and the business was slowly growing. We were getting more customers, and as the traffic grew, some scaling issues come up, and they are managed. And this is great. We could keep growing, and a different thing comes up, and it's managed. And as the pace of growth goes along, these things happen, but each time there are side effects that sort of push out a little bit further. And what you wind up with is a system that is still there and working well, and just creaking, and it starts to push its boundaries more frequently in different ways. It's not patterns, it's rough. And we saw, as a business, we wanted to grow, and we're realizing that what got us to that part in our company's life would not get us to the next one. So I would like to talk a little bit about how we managed that. This talk is a collaboration. My name is Ben Hartshorne. I'm a principal engineer at Honeycomb. I've worked on this talk with Jess Mink, who unfortunately could not be here today. They joined Honeycomb as a senior director of platform engineering. When we were facing this, they started and we said, welcome. Very glad you're here. We would like to double the size of our business. Please help. So we needed to get a lot of work that was on the periphery here, somehow scheduled in the face of growing the business and increasing the product and everything else. And honestly, the thesis is relatively straightforward. A compelling business case is what will get your work scheduled. So we need to understand, what does a compelling business case look like? How do we get there? How do we ensure that we can do this for technical work? Because the company has been growing, and the product organization has been growing, and there's more sophistication around deciding what we should build, and we need to match that. So I want to start by thinking about, what does it mean to understand priorities, just a little bit. It's a truism in the startup world, and probably in all of the business world, that there's always more work than you can possibly do. There's this herd of features out there. They are beautiful, they are product ideas, they're things you can do, new things you can build, ways you can improve, and they all must go through this gate of your engineering capacity. You can only do so much work. So we're starting from this perspective of there's no way we can do everything, right? And the engineer's view on this herd is on the inside of this fence. There's this line of beautiful work coming in at you. It is full. You have your roadmap, you have all of your work queued up, you have the new products to build, the existing ones to improve, and you look at this and you think, how can I possibly do the work that I see that we need to do in order to maintain this business? When do I schedule this? Can we close the gate for a little bit so we can like sweep the entrance? That's hard. But take for a moment the other perspective, the product managers, the ones who are creating this curated list of things for you to do. This is their view. They see this enormous pile of things they would like to build, ways the business can improve, and they're not going anywhere. Why isn't engineering doing our work? They ask. So they see this as an enormous opportunity and need to figure out, okay, engineering has the capacity that they do. We need to understand which sheep to offer them, which are going to make it through the gate first. So this is what a little bit about what they do. Let's imagine this sheep in the front here. This sheep in the front will reduce your hosting costs by 20%. Very good sheep. We should do this, right? Any project that might show up has to be considered in the context of what the business is doing, what's currently going on everywhere. So imagine we are a primary color company who does some web search, and we have the opportunity to reduce our hosting costs by 20%. This is a career-making move. This is going to happen. Right? It doesn't matter really, well, it matters a little bit how much it costs, but this is a project that is absolutely going to happen. But picture this middle group here, classic startup scene, they're early in their business, they have the same opportunity to reduce their hosting costs by 20%, but their hosting cost is what, like $300 a month? No. No, you're not going to do that. And then there's all of the states in between where your business might be in a merger, or it might be in a reorg, or there might be something going on, and you have this obvious benefit, reduce hosting costs, but it's really not clear whether you should do it. If the reorg is incomplete and the entire product that's being hosted there is going to be disbanded, no, don't go spend time reducing the costs to host it. So the same project, the same decision, the same idea may get a very different result depending upon what's going on in the rest of the business. So let's look a little bit more at how to choose which of these things to do. It's not always quite so simple as an enormous cost reduction. Product management has come up in this track before, and there are sophisticated tools to help product managers take this enormous mountain of ideas and input and form it into the things that they are going to present for engineering, to understand whether or not one of these things should be done. This input comes in many forms. There's feedback from customers. There's ideas sprouted from, well, anywhere, really. There's appreciation for a specific aspect of your business. And all of these come together. They come in separately, but they need to be understood to be representations of a thing that the business does, a service that it provides, a problem that it is solving. So you can look at each of these different bits, whether it's a piece of customer feedback that comes in, and try and reframe it so that it is shaped like a problem that the business is fulfilling. Now, this process is managed for every one of those sheep we saw, and what we wind up with is this enormous corpus of data about all of the different problems that we are confronting as a business, which ones affect our customers in one way or the other. Some of them are, blocking new customers. Some of them are allowing the expansion of existing customers. Each one has this depth to it that has been accumulated by the product organization. Now, once you get an understanding of these ideas, you can try and tease them apart into a couple of categories. There's the obvious good, the obvious bad, the big squishy middle. I particularly love this graph. I first came across it in a workshop by a guy named Jeff Patton. And when I went to look for the image that he used, found he credited it to a graph called Constable's Truth Curve, which was in fact presented here at QCon in 2013. On the left there, you have the size of a bet you're willing to make for this particular piece of work. And on the top, going across, is how much you expect to get from that. Now, let me give you an example. I have a new feature that is going to make you several millions of dollars as a business. It's going to take quite a lot of time. So it's up there with the green dollar sign. And you ask me, all right, so you're proposing this thing. We recognize all development is a bet. How confident are you? You say it's going to bring in this much money. What's the likelihood you're wrong? I say, well, I think it is, and if I'm wrong, I'll buy you a cup of coffee. Yeah, maybe don't take that bet. The green is equally clear. You have some relatively easy task that has a very clear return, and you're very confident. There's no question about whether this will actually benefit the business. I'm willing to give you my car if I'm wrong. Yeah, we should do that. That's in the nice green section up there. And the squishy middle is like most of everything else. So we need tools to help us explore these ideas and better understand where they fit, and in hopes of pushing them out of that squishy blue middle into one of the other edges. There are a couple of good sort of thought organizing frameworks out there. These are just two samples, an opportunity canvas, a learning canvas. They're both ways of taking your understanding of the problem, of the people it will help, of the people it might not help, of the cost, structuring it in a way that facilitates some of this conversation. Ultimately, the goal of this process is to clarify the ROI, the return on investment of any given piece of work. We need to find out who this work will influence, who it will impact, how much, and how much those users care about this particular thing. If it makes a big difference to some aspect that they never use, maybe not so important. So this is a big part of the process of product management, is understanding all of these questions. Now, I've spent a while talking about this. It seems like a lot of work. We're here to talk about tech debt. The thing is, yes, it is expensive, and software is more expensive. This has come up a couple of times in this track, too. Engineers are expensive. Engineering efforts are expensive. And I don't want to just focus on us as individuals doing this work. You'll hear somebody say, oh, this is about like one engineer's worth of salary for a year for this project, so if it'll take us 3 months, we should do it, that sort of thing. That's not enough. There's a metric out there published by a number of public companies. It represents revenue per employee. Now, we're beyond engineering here. It's not revenue per engineer, revenue per employee. This is what each employee of the company represents in terms of value that they are building in order to bring the company to a good place. So if we do a little quick math, engineering is usually maybe 35% of the company. Look at those numbers a little bit. We're talking about $1 million per engineer in terms of the revenue they're expected to generate through their work. And for high-performing companies, this is even higher, 2 to 5 million. Our time is expensive. It is worth a lot. We need to recognize that in order to value the work that the product organization has been putting into how they're curating all of those sheep and to choose which ones they're going to let through this gate. They are putting an enormous amount of respect on our teams in order to choose the most impactful projects for us to build. When we think about tech debt, we think about a thing that we need to do that's outside of this regular stream of work. We think that our piece of work should jump the queue. This database upgrade is important. We have to do it. Do we? Maybe not. What's the business value? What's the return? How can we measure this piece of work, this feature, in the same language, the same framework as all of this effort that's been put towards the rest of the work that is coming to us from the rest of the organization? We'll hang on to that question for a moment. So we talked about, obviously we can't do all the work. The prioritization, we are going to base strongly in a business case both the return we get for doing the work, also the cost, the investment we put into doing the work, and then that business, that balance, the balance between those must exist in the context of the business and what's important for the business at that time. Okay, costs, the cost of the work, very good. Let's talk about what we get back. What are we going to get for this project that we need to do? We've seen our work queues look like this. We need to upgrade the thing. We need to move the other bit. We need to refactor this. Y'all know what this is, right? This is tech debt. We can tell. We look at it. We see, yep. In order to focus it back on the business, I want to think a little bit more about what tech debt is. I did hear a couple of folks mention it earlier in the day. The things mentioned weren't any of those. It's hard to say what tech debt is, so let's answer the easier question instead. What do we do here? This is a wonderful graph that the VP of Engineering at Honeycomb put up in a blog post, understanding what goes into engineering work. On the left side, we have all the things that are customer-facing. The features we actually build, also customer escalations and incident response, bug fixes. On the right side is all of the stuff that's behind the scenes. Customers only see that part when something goes wrong. Tool chains, refactors, training, testing, compliance, upgrades. Okay, let's split it the other way, up top. We think engineers are responsible for writing code. Well, that's true. The stuff up top, this is in code. This is adding new features, removing features. It's also the upgrades. On the bottom, we have all of the attributes of running a system that are in production, that are not in code. This is going to be part of your CI/CD system and your deploys, your training, your QA, also your incident response. The things you need to do that are part of owning your work and in a modern software SaaS system. All of this is part of an engineer's regular job. So which one is tech debt? Maybe? I think of tech debt normally in terms of refactoring, of dependency upgrades, of work that you have to do in order to, reform the product to fit some new business shape. But really, every category outlined in red here can be described as technical debt. I loved one of the examples from yesterday about doing feature flag triage and leaving your feature in there just long enough so that you can reuse your feature flag when you're putting in the next one, and so you delay the removing some code. It's not just the stuff in back. It's not just the stuff that you think of in terms of refactoring. And there's a problem here when we're using a term so consistently and we all have different definitions. It really muddies the conversation. So when I'm talking to somebody and I say, here's this piece of tech debt, we need to spend some time on it, and they hear something that's in a completely different portion of this circle, it does not aid the communication. So perhaps we can just stop using the term. We're going to need to talk about work in a business context anyways. And I'm sorry, I know tech debt was in the title of the talk, and here I am saying it shouldn't be. I didn't want to title the talk, Put Engineering-Driven Work with Business Value on the Roadmap. A little bit much. Okay, so the goal of this work, though, is the same. It's getting it on the roadmap. As engineers, one of the things that we do is translate language that we see into understanding how that will affect us and our systems. There's an observability company out there whose website has a big banner on the front, find your most perplexing application issues. When I look at that, when we as engineers look at that, we're like, okay, how? I want to fit that into my product. I want to understand how I can rely on it, where I can rely on it, where it will help me, where it won't. How do you do this? What is it? And we'll make a translation in our head. Honeycomb is a tracing product. Not going to get into that as a translation, but I believe it is a good example of what goes on in our heads. And this translation is very useful when we're building systems. And when we're trying to explain business value, it leads us to talk about we need to upgrade the database. Not so helpful. So we're here to flip that around a little bit. As we are trying to understand how to prioritize and schedule the work that we see within engineering, we need to understand how to switch from talking about what it is that we need to do, upgrade the database, and start talking about why we need to do it so that we can connect it back to this business case. Sometimes that takes a couple of tries. So we talked about needing to upgrade this database, or maybe not. Do we really? Let's ask the team, why do we need to upgrade this database? And they tell us, oh, actually, it's hitting its end of life. Yep, it's an EOL database, we need to get off of it. Do we, really? It's still serving our queries, right? Okay, so in this mythical world, even that isn't good enough. Let's say that our hosting provider says we will not run EOL software, so you have 4 months, and then we are shutting it off. Now we see, okay, what happens when they shut off our database? The entire product stops working. So we need to upgrade that database because we want the product to continue. If you go to your sales reps and say, hey, would you like our product to stop working next September? They will say, no, please schedule the work you need to do. I would like you to fix that. How can I help? Who should I talk to? I will help you get this work scheduled, because it is clearly connected to ensuring that the business can continue. Okay, hosting providers usually don't go in there and flip off your database just because you're running an EOL version of MySQL, but I want to tell another story, and this one's a little different because I didn't actually get the business case until after it had happened. We were running an old version of a LaunchDarkly library. LaunchDarkly does feature flagging, and it was fine. It worked, but there was one team that they had some extra time, they upgraded it, they had a thing they wanted to try. There was a shift in the model of this library from thinking about a user as the thing that manages a flag to thinking about a context. Intentionally more broad, the context pulls in all sorts of other attributes of where this flag is being executed, and this team used that to flag on their feature for a single node and get a very nice comparison graph. This was awesome. Within just a short period, many other teams were doing the same thing and getting to see, okay, I can do a percentage rollout, roll back, I can flip it onto these. We were used to only flipping it on in some of the data that is more relevant to our application. It opened up a whole new window. We saw, hey, we can safely canary changes in a way that we couldn't. We can do A/B testing in a way that we couldn't. This is amazing. Gimme. If we had been able to see that business case, that we can make our engineering teams able to deploy their software more safely, more quickly, with more confidence around the change, get better understanding of the impact of the change, we would have been able to prioritize that work. It was lucky that it was not so much effort and that one team had the space to make it happen. But this idea of finding the business case in order to do the work, sometimes it takes some effort to understand what is going to happen with this. And that can feel a little squishy. So we are engineering teams here. We have a magical power. We can create data. We can find data. Our systems give us data. If they don't have the data we need, we can make changes to those systems. We can commit code to get more data. And we can use this to back up all of our arguments. So when we get one of these conversations like, well, I think it's going to do this, and someone else says, I think it's going to do that, we can find out. SLOs, top of the list there, they are my favorite tool for mapping business value back to a technical metric, because in their formation, they are representing the experience of a user. They're encoding what does it mean for a given experience to be successful or not. How many of those experiences are we allowed to have fail? Over what period of time before we hit a threshold where our users and our customers get angry and leave? I would love to spend the rest of the time talking about SLOs. It is entire talks on its own. I will reference you one, I have a link at the end. Liz Fong-Jones did a talk on, it's published on InfoQ, on production excellence with a fantastic segment on SLOs. But they are not alone in our sources of data. We have all of our metrics showing various limits of our services. We get to do chaos experiments. When we have a service and we're not quite sure what that limit is and we need to know more, we can artificially constrain that service in order to push its boundaries and find out what we would otherwise find out in an incident 6 months down the road. And well, of course, there are those incidents. They really are two sides of the same coin. And I don't want to leave out qualitative surveys. Often a piece of technical engineering work that fits into this category of tech debt may feel like its target is not a specific amount of money for the business, but facilitating one's experience in a certain part of the code base. You know, there's this idea of haunted graveyards, the section of the code where people fear to tread. Because it's dangerous, it's complicated. And cleaning those up is valuable to allow the business to move forward. Some qualitative surveys can really lend credence to this as you ask your engineers, how was it to build this new feature? How was your feature flag experience? With all of this data, it's easy to fall back into those old habits. Oh, we need to upgrade the database because the CPU is too high. Well, who cares? You gotta bring it back in business context. Take that language about the CPU is too high and translate it to what effect will that have on our ability to run our business. All right, so we're back to our list here. We want to get this work prioritized, and to do so, we understand what is important to the business here, now. We take the projects we need to do that we see are obvious and understand how to translate that into something that's based on impact rather than the technical change that we wish to make. And we find the data we need to back it up. So I want to take you back to the Honeycomb experience of a year and a half ago, with this system that has been growing and is starting to creak and fail in other interesting ways. Let's run this playbook. Let's see what happens. Start with understand the priorities. Honeycomb is a SaaS business. We are software as a service. ARR rules everything. This is annual recurring revenue. This is how much people are paying us, whether it's monthly or yearly. It includes people that decide to leave and end their contract with Honeycomb. It is a big deal. ARR is this number that we have on our fundraising decks that we talk to the board about, that we make projections for. This is what we are organizing our business around, saying that we're going to get to this amount of revenue and we're going to do it in this amount of time. I know there are many talks here about the balancing, reducing costs and expanding revenue. For many SaaS companies earlier in their life, the balance is heavily skewed towards revenue. ARR is the thing. So let's use it. We get a dollar number of our ARR target, but that doesn't translate to upgrading a database. So by talking to the sales and product team, we get more detail. Because this number is such a big deal, there's a lot of research and work that goes into building it. It's not just a number. It's not just throwing a dart or watching a curve and saying, yep, we're going to make it there. No, they know we're going to get this many customers of this type, and we're going to see these many upgrades, and we're going to see this many folks leave. All of this comes together to form that top line number. Now, it's wonderful that we have descriptions of who we're going to get. Still doesn't help, because I don't know how to work with dollars, but they have more answers. When I ask, okay, you're getting 10 more enterprise customers, what does that mean? Which of our current customers can I model this after? How are they going to use our product? They came back with answers. They're like, okay, this group of customers, they're going to be focused more on ingestion, and they're going to use fewer of these resources. These other ones over here, they're going to be more of a balance. Those ones there are going to be very heavy on the API. Now we're getting onto my turf. We're getting to numbers that I can see, the numbers that I have graphs about, and I can now use this information to connect it back to the business value that's going to come from each of those things. Okay, so we need to take this data and map it to our infrastructure. Honeycomb is a macro service architecture. We have a smallish number of relatively large services. They are all named after dogs. So we're applying these to our infrastructure here. For each of these teams that have a dog under their care, we ask these teams, please spend some time understanding your service, writing about your service, and reflecting upon how it fits in here. So start with just an overview of the service, and then think about where the bottlenecks are, how the service scales. Then look at the sales targets that we covered, that we have these numbers for, and write down which ones of those are applicable to your service. You know, maybe ingestion matters, maybe it doesn't, depending on what the service consumes, who it talks to. Some are important, some aren't. This is where we involved all of engineering. Every team did this. It didn't take all that long. Our SRE team is already embedded in each of them, and they helped by guiding them through some of these processes to like write down and give a unified format to these reports. As an example, our primary API service. This is the front door of Honeycomb's ingestion. It accepts all of the telemetry from our customers. It does some stuff to it, authentication, authorization, validation, transformation. It sends it along to the downstream service, which is a Kafka cluster for transmission to our storage engine. So it has some dependencies. It depends upon a database for authentication tokens. It depends upon a Redis cluster for some rate limiting and things. The upstream services are our customers. The downstream services, well, it's Kafka. The sales target affecting the service is clear. It's the telemetry that our customers are sending us. All right. When thinking about how it scales, it is a standard horizontally scaling service, stateless. These are like the canonical scaling things. It can grow as wide as it wants. Yeah, almost. Through some past experience, both planned and unplanned, we have discovered that as the number of nodes grows, the load on the database grows. When we get to about 100, the database starts to slow down, which means you need more nodes, which makes the database slow down, which means it goes boom. So that is clearly a scaling limit. Good, we have it written down. Now comes the fun question. We found this scaling limit. That's great. We have to fix it, obviously. Well, maybe. Let's take these sales targets and say, okay, where are we going to be on this curve of our sales target? When are we going to hit this scaling limit? Is it within the next year? Do we need to fix it now? Is it a problem for future us? Let's decide. Well, for this one, as it turns out, we expected to hit that volume by mid-year. So the database thing was one that we had to focus on. We got this whole report. It did highlight the database load that we will hit before reaching our sales targets. Also called out a couple other ones, and some that we don't really know about. So those are a cue for running some chaos experiments or other ways of testing our limits. The business case came down to this one. it was very clear. We could go back to our sales team and say, we need to schedule some work to mitigate the load on this database as this service scales out. If we don't, we will not hit the sales targets that you gave us. And the answer is very easy. Yes, please schedule that work. How do we need to do it? We did this for all of our services and came up with a lovely Asana board showing some things to fix, some things to care about now, some things that are probably relevant in the year, some that aren't clearly like yes or no, but might extend the runway so we can keep them in our back pocket and understand that if we see something creeping up, that's a thing we can do to make it work. There's one tag, it may be difficult to read because of the coloring. It's called Explodey. You'll see the label Explodey on some of these. As an organization, there's this fun side effect to this exercise that we got to talk about a couple of things that we don't always cover in the regular day-to-day engineering. Explodey is one of them, and that's a description of this API service horizontal scaling thing that I was talking to you about, right? It grows, and you don't really see much until you get to that threshold, and then boom, everything comes crashing down. Those problems are scary and huge, and also you don't usually have a lot of time to react between once that cascade starts and when you hit the boom. So it helps you understand a little bit about how to schedule that kind of work. The non-explodey ones, as an example, if you have a service that runs regularly scheduled jobs, once per minute you run a job, and over time that job takes longer and longer until it takes like 65 seconds, and when it's overlapping the next one doesn't start, that's not explodey. Some jobs won't run, most will. It will degrade, but it will degrade slowly, and it will degrade in a way that you can go back to those SLOs and use that to help you figure out when to schedule it. So equally important problem, slightly different method of scheduling. The last bit here, I don't know how many of you have had a conversation with somebody when designing a system. We look at this diagram and this architecture and say, oh, no, that can't scale. Nope, we can't do it this way, that won't scale. And it's a struggle because yeah, okay, maybe it won't, but do we care? Will this system work for us for now? There's the classic adage of don't design things the way Google does, because Google has 100 million times your traffic, and you will never encounter those problems. If you follow that design, you're doing yourself a disservice. So this scaling problems, which ones to ignore, this mapping of sales targets to scaling limits is a very strong way to have that conversation and make it very clear that from the business perspective, we can wait for that one. Cool. We caught ourselves a strong business case, using the priorities of the business to get time to fix some of these problems and the choice to put some of the other ones off. We are now done, right? We have gotten this work scheduled. Almost. There's one more step here, which isn't so much about getting the work scheduled in the first place, but is about making our jobs as an engineering team, especially in a platform, a little bit easier the next time around. We need to celebrate. We need to show the success of this work that we're doing. When we find one of these projects and we finish it, we need to make it very clear that we put engineering effort towards a business problem in a way that has given us the capacity to grow the business in the way that we need to. And then when we have finished it and it's gone on and we pass that threshold that was previously impossible, we can call it out again and say, hey, remember this? Yeah, we couldn't have gotten here without it. This stuff is really important. It lends credence to our discussions in the future about what's going to be happening when we have more technical work to schedule. And the last one, this was a fun experience from a near-miss incident several weeks ago. there was some capacity issues, and we were struggling to grow the capacity of a service quickly enough. And during the course of this near miss, one engineer bemoaned, "Oh, it takes 3 whole minutes to spin up new capacity for this service." This engineer had been at Honeycomb for a couple of years, but that was still recent enough that they didn't remember the time before we were in a Kubernetes cluster when new capacity took 15 minutes to spin up. We put up a big project. We're gonna change the way we're doing our capacity and the way we run our services. We're gonna set a target of 10 minutes for new capacity, new services to come up. No, let's be aggressive. Let's set it to 5. And here we were, recognizing it takes 3 whole minutes. I mean, this is great. This is amazing material because it gives us an opportunity to reflect on where we've come. And for a lot of the platform work, for a lot of the tech debt work, that work is almost invisible. And we need to find ways to bring it to light so that we can see as an organization the effect that this work is having on our longevity, on our speed, on our ability to deliver high quality software. So this is the recipe for getting technical debt work onto the roadmap. Understand what your business needs. Understand the impact of the projects you need to do to reduce that technical debt on the success of that business. Frame it in a way that is communicating that priority, not just the technical work. Use our power of data to back it up, and remember to ensure that you talk about the effect it had once you're done, and that effect has been realized. The business is exceeding those limits that it previously saw. And thank you very much for your time.
Thanks a lot for your talk, and thanks for choosing lots of cute animal pictures. So you did a really wonderful job of establishing a shared language or a shared vocabulary framework for presenting sort of the business benefits of things. What about scenarios where you have potential security issues, right? So a scenario where I need to upgrade the library because there is a potential for a remote exploit on X. At which point now you're just sort of projecting what the potential damage can be. So how do you sell that?
Yeah. Forgive me if I rephrase your question. How do we express security concerns in the language of business impact? I will admit our security team is very good at that. I am not so good at it. But there are a couple of ways. So for larger businesses, there are frameworks that they are required to operate under for security. There are agreements that one makes with both sub-processors and with customers around the response time to certain types of issues. And you can use that to leverage, to build an argument. If we are contracted to respond to a security incident within 30 days of being notified, we have to. So you were asking about upgrading libraries because of potential flaws. That is definitely fuzzier. So I was talking about how projecting projects that you're going to make are bets. How much are you willing to bet that this is going to have that impact? Is it a cup of coffee? Is it a house? Framing security in terms of bets it carries a little bit of a different feel to it, and yet that is what's going on. None of our services are 100% secure. We are doing risk analysis to understand which risks we are willing as a business to undertake and which we're not. Do we have the recourse of the legal system if this particular risk manifests? I know our business has and I think most businesses do have large documents describing their risk analysis for the current state of the world. The risks from inside, the risks from outside, the risks from actors, third-party actors, and so on. I think all of those are tools one can use to better assess the risk of a particular change, and those all come straight back, again, to business value.
I've often found that one of the hardest types of tech debt problems to get scheduled, to get approval on, to get buy-in. It's the kind of problem where the benefit that you're going to get from it, from solving it, is freeing up your engineers to improve the velocity, right? Like, so you have some task that really should be automated, but the amount of work to do to automate it is going to take a couple weeks. So we don't do it, and in exchange for that, somebody has to do it manually once every couple weeks, and it takes them 3 days to do it, and it's like an invisible cost from outside of the engineering organization, but you know that it would free up a whole lot more engineering bandwidth to work on features and other things as a part of their future. So I wonder if you have any thoughts on how to frame that as a business objective that would actually be worth investing in,
Yeah, thank you, I do. If I can rephrase, how do we schedule work that is toil, that our engineers are doing successfully because the job's getting done, right? So there are a couple of ways. The first I want to highlight is the product philosophy of incremental deployment, incremental improvements, shipping the smallest thing. There's a wonderful diagram of how to build a car, and one path starts with a set of wheels, and then a frame, and then some shell, and then the engine, and then at the end of it you have a car, which, great, you can't do anything until you get all the way to the end. The other says, well, maybe start with a skateboard, graduate to a bicycle, maybe a motorcycle, and finally you'll make your way to the car. So I reference this because a lot of those types of toil tasks can have small improvements that incrementally transform the task. As an example, you might start with a person that needs to roll the cluster by hand, and they go through and they kick each server in turn, and on they go. Simply writing that down in clear language, forming a checklist for it, makes the next version faster. You can take 2 of those checkboxes and transform them into a script, and it makes it faster. So each one of those is significantly easier to find the time to do than the entirety of the toil. So that's the first one. And the second is to bring up again the idea of qualitative surveys. We ask our on-calls every time they start a shift and every time they finish a shift a number of questions. It's a light survey. Did you feel prepared for your shift? Do you think the level of alerting we have is too little, too much, just about right? What came up during this shift? Did you feel stressed about any particular bit? What was the hardest part of this shift? Collecting those on a quarterly basis gives us some really good and unexpected insight into some of the types of toil that are coming up. Maybe it's a flappy alert. Maybe it's some service that needs to get kicked and needs some improvements in its operational controls. Those are data. And we can use those to say, hey, listen, our on-calls are spending 40% of their time chasing down false positives. This is wasted effort. And that brings it back to expensive engineering time, and is, I think, a pretty good road into a compelling argument to spend some time improving the situation.
Fantastic. That is it for the time, folks. Thank you very much once again, Ben.
Thank you very much.